Our next speaker is Dr. Austin Becker. He's an assistant professor of coastal planning, policy, and design, and director of graduate programs in marine affairs at the University of Rhode Island. His title is Stimulating Transformational Thinking for Long-Term Resilience Planning, Port of Providence, Rhode Island Demonstration Project. Professor Becker is an assistant professor of coastal planning, policy, and design in the Department of Marine Affairs at URI. His teaching and research focus on sustainable design, port planning and policy, GIS, and climate change. He is a regularly invited speaker at international expert group meetings as well as numerous conferences in the U.S. He earned a BA at Hampshire College, a Master's of Marine Affairs and Master of Environmental Science and Management at URI, and a PhD in Stanford University's Emmett Interdisciplinary Program in Environmental and Resources. He maintains a U.S. Coast Guard 500-ton captain's license for ocean-going vessels. Professor Becker is also an associate of the University of Manitoba Transport Institute. Professor Becker.
Thanks so much for having me. This is a really interesting conference for me to be at. Very diverse range of topics. And you set me up well, putting me right after Admiral Baffer, who provided some nice real-world examples of some of the issues that I'm going to be talking about. So the work that we do in my research group in the Department of Marine Affairs is really trying to answer this really broad question. And I consider this to be the life work of myself and like all of my students for the rest of my career. How can a more holistic approach to planning reduce climate risks within the environmental, social, economic, and political landscape? And we are trying to answer this question through a number of projects. And I'm going to talk about one of those projects today. But I'll try to mention some of the other ones because they are all interrelated. So I'll frame out the problem that we're trying to address in terms of sustainability and climate risk, and then walk you through a demonstration project that we did this past summer up in the Port of Providence. We've heard a little bit about coastal hazards. I think at this point people are pretty familiar with what some of these challenges are. The challenges for Rhode Island are the same as the challenges for many places around the U.S. and around the world. For our port systems, and I study port systems because they're critical to the global economy. They're also critical to the local economy. And they're very complex systems that make a good lens through which we can try to understand some of these issues that we're going to be facing with climate change and coastal hazards in the future. So the big ones for our ports and the big issues for our ports and coastal communities are, first of all, this projected doubling of Category 4 and 5 storms by the end of the century. So we're looking at the strong possibility of having more Hurricane Sandys, more Hurricane Katrinas as we move forward through the century. Sea level rise, of course, is a big problem already in many areas, and it seems like every time I read a new science paper about sea level rise projections, the numbers get worse. So right now, the projections range anywhere from 3/4 of a meter to about 2 meters by 2100. A new paper just came out reinforcing that 2 meter mark. And then inland flooding issues are, of course, a big problem. And if you kind of bundle these all together, as some researchers have done, you end up with what is today the 1% annual probability storm event, or the 1 in 100-year event, becoming as much as the 1 in 3-year storm event by 2100. So this is a really significant challenge that we're going to be facing and that future generations are going to be facing moving forward towards 2100 and beyond. And it's what in the research world, in the academic world, has been called a wicked problem, which New Englanders love that it's called a wicked problem. But this really, this means it's a very complex issue. There's no one easy way to define what the problem even is. There are very few or no kind of absolute solutions to the problem. Any resolutions that you can propose are likely to generate other complicating problems. And the solutions that we can find are usually neither good or bad, that there are always winners and losers associated with these. So for the climate change issue in coastal communities, we're dealing with an uncertain rate of change in terms of sea level rise and those storm events, complicated feedback loops with greenhouse gases, a misaligned incentive structure, so sometimes it can be in an individual business or even agency's best interest to not do anything. The funding streams, we know it's going to cost a lot of money to address this problem, but where that money is going to come from, not so clear. And the options for adapting to climate change are very complicated and will have some winners, perhaps, and many losers, as I mentioned. So this results in this problem of befuddled decision makers. And that's what the research that we've been doing in marine affairs is trying to grapple with, is how do we kind of untangle some of these problems so that people can engage with them a little bit more directly. So we've been developing a number of tools to help people engage with this dialogue around sea level rise and coastal hazards. And these tools, which they're also known as boundary objects in the academic literature, they help people to engage with a problem. So they might be maps, or they might be, they could be performance art. I'm not going to do any performance art today. But they're things that help people to understand what a problem is and come from like a neutral space. So we developed 3 tools and then implemented them in a workshop process this past summer with the Port of Providence. And we wanted the stakeholders of the Port of Providence, which are both on the private side and the public side, so there's government agencies who are stakeholders there, and there's a number of private businesses. We wanted to bring them together to help understand what the long-term consequences of, say, a Hurricane Sandy might be for this particular port. So we presented a storm scenario. We developed some long-term planning concepts, so not so much the things that you can do to respond to an emergency as it's happening on the ground or in the week afterwards, but how can we think decades ahead to prepare for more of these kinds of events and to prepare for the sea level rise factor. And then we looked at some long-term resilience goals that the individual stakeholders had and used a multi-criteria decision support tool to help them engage with the pros and cons, the costs and benefits of these long-term, really big strategies. So I'm going to show you what we did here, and then I'll end with some of the major findings and recommendations. So here's our port of interest. This is the Port of Providence. For those who don't know, the city of Providence is right up here. It's protected by a hurricane barrier, never tested in an actual hurricane, but there is a hurricane barrier here that hopefully will protect the city. However, the industry is all south or seaward of that hurricane barrier along this area here and a little bit on the East Providence side. So there's about 30 businesses in this area, water-dependent businesses. It's a major energy port, so should this port be shut down, we would lose petroleum products for the whole state for that period of time. Gas for cars, home heating oil, jet fuel for TF Green Airport, etc. And it's a pretty significant employment center. So we brought together about 30 stakeholders from this port, from businesses like this. This is Metals Recycling Inc. in the port. This is Provport. This is a salt pile. So all of the salt for roads, which we ended up needing yesterday and today, comes through the Port of Providence. Hudson Asphalt is here, and this is a coal pile. And you can see that the port is it's fairly low off the water here. And another picture of Metals Recycling Inc. here, which exports scrap metal. So our first tool that we developed to work with this group of stakeholders was a storm scenario. So we chose kind of a worst case but plausible storm, a Category 3 hurricane that would have devastating damage. It's basically the same as the hurricane of 1938, but shifted over to the east. So the storm track was shifted to the east. And this is a storm, this was a deterministic scenario. So we chose this particular event because we wanted a storm surge for our scenario that would not overtop that hurricane barrier that I mentioned up at the northern end of the harbor here. Because we felt that if we produced a storm scenario for our participants that overtopped that barrier and flooded out the entire city of Providence, that would really be a game changer. It would make it really tough for people to engage with what was going on down here when the entire city was underwater up here. So this is a plausible event. It's a 21-foot storm surge, which is what the hurricane barrier is designed to protect against. And this is, your basic flood map that shows the depth of inundation at various parts around the port. And in order to help our stakeholders engage a little bit more deeply with this, we developed some fairly simple 3D visualizations of their actual properties. So this is Provport here, and these are some 3D buildings. And this is technology that we're working on right now in my group. We have a student who is very good with developing these kinds of visualizations, and we're working on a much more complex version of this, but this is what we had at the time. This is off of Google Earth. Here's that metals recycling Inc. area, and you can see the water inundates all the way around, except for the tops of the piles. Motiva, one of those energy facilities. And you can notice here that there are berms around some of these petroleum storage tanks. But these berms are containment berms. So they're designed to hold the product in. Should there be an issue with this tank, it would hold that petroleum product in. They're not designed to keep the water out, the water pressure out. So it's a little bit unclear how well these kinds of structures would hold up in this kind of an event. And I'll also just remind you that we're looking at kind of a passive inundation here, so there would be wave action on top of that. Another one of our energy facilities here, and this is looking north towards the city. The city's up here protected by that barrier. And we worked with the stakeholders in some breakout groups to try to identify not so much what would happen on that day, but what would happen in the weeks and the months and even the years after that event, to help spark some dialogue around how to start thinking about what the real risks are on a long-term basis from these kinds of events. So lots of things bubbled to the surface with this. Obviously, losses of critical facilities came up. Debris was a major problem that people talked about, a disruption of commerce, major environmental impacts to Narragansett Bay, which could last for months or even years after this event, especially with some of those petroleum and chemical facilities that are in the area. And then a lot of unknowns, we know that there would be environmental impacts, but we don't really know how bad it would be. So this helped people think about what this storm might do. And the next tool was the introduction of some long-term kind of transformational planning concepts. And these are large-scale changes, on the order of $1 billion to protect an area like this against these kinds of Hurricane Sandy scale or Storm of 38 events. So we introduced 3 of these concepts. The first was a major investment in site-specific improvements. And you're going to hear more about these kinds of improvements from Robin Peach from Massport, who's speaking next. You already saw some of these examples from Admiral Baffer. But these are things like elevating utilities, elevating the actual land underneath the port itself. This is an example from Gulfport, Mississippi. Another example from Gulfport, where they were proposing to actually elevate the whole port from its elevation of 10 feet above sea level to a new elevation of 25 feet above sea level in order to get the entire port infrastructure up and out of the floodplain. So this accommodate strategy would implement many of these across the entire study area. The second strategy was to relocate. And we've seen pictures of the lighthouses being relocated. I have to say that the industries who were represented in this workshop were not very keen on this relocate concept. In fact, they didn't want the word relocate in the workshop at all. They were very anti-relocate. But what we mean by relocate is either moving a facility completely out of the floodplain, or, as this example in East Providence that I'm going to show you, just moving some of a facility out of the floodplain. So this is the ExxonMobil terminal in East Providence, and you can see up here at elevation 50 feet is the petroleum storage tank. Now, this was not done as a resilience measure. It was done because this was the land that was available for this, and there's a piping system that comes between here. But this is in place today. But this is the kind of thing that could be done to some of these other petroleum facilities in this area. So relocate, of course, has lots of complicating factors. It's very expensive. Where would you put the things? You'd have NIMBYism wherever you went. But it is a possible strategy. And then the last large-scale transformational concept was protect. And in this case, we proposed a new storm barrier south of Providence Harbor here. So a current barrier is up here. So this barrier would get removed, and it would get a new barrier similar to the one in Rotterdam, which has these gates that float closed to protect from a storm event. And there's some other implications of this. You could have some floodwater storage for the riverine systems. You'd have some room for new development where the current barrier is, and then a berm system that would protect the Fields Point area here in Providence. So these were the three large-scale concepts. I think, in reality, if any of these were done, there would likely be a combination of all three. But the purpose of this was really to start some thinking and start some talking and start some grappling with this huge problem that we're going to be facing for the next century. So the third and the final tool was this multi-criteria decision support tool called WeCision, which is the one we use. There's lots of these tools out there. We went with this one, where we worked with these stakeholders to ask them how well these different long-term strategies would meet their resilience goals, and then how well their different goals, how important each of these goals was to them. So they identified 7 of these resilience goals, and then they kind of looked at each goal and looked at each strategy and developed some ranking and weighting systems, which resulted in a graph that looks like this, which doesn't mean that this is the right choice, but it does mean that given the goals that these particular stakeholders had, this choice of protect building that new barrier would serve those particular goals that they had identified best. So despite their discomfort with the idea of relocate, when they looked at it just kind of objectively, it came in number 2, even though it was certainly not a favorite in discussion. So this exercise led us to some preliminary findings. First of all, with this group of stakeholders all around the table, we really found that there is no long-term plan for improving resilience for major hurricane events. So there's great plans for emergency response. The Coast Guard does a terrific job with leading the charge on that. There's evacuation plans, there's facility shutdown plans, things along those lines. But there isn't really any long-term planning effort to try to address what some of these new challenges with climate change will be. It was really tough to get the private businesses to come to the table for this exercise because it's hard for them to see what's in it for them at this point in time. So nobody's proposing to do anything differently yet. We're just trying to understand what some of the options might be and how we start talking about this. This is the kind of problem that really cries out for a champion. Somebody, a government agency, an individual to say, we need to improve the resilience of this commercial working port. And at this point, that person has not yet emerged. These kinds of long-term planning concepts are very difficult to quantify in terms of cost. Everybody wants to talk about how much it's going to cost. Well, there's a lot of implications, there's a lot of factors at play with this, and putting a number on it is very difficult to do. It can be done up to a certain point for something straightforward straightforward like the hurricane barrier proposal, but moving some of these uses, opening up land, making incremental improvements, they're hard to find costs for. And these tools that we developed, they were actually quite effective at getting people to start talking about these issues. And we've already seen evidence of some of the results from this workshop kind of percolating through the system in Providence and Rhode Island, where some of the concepts discussed here, we're hearing them come up at other public meetings. So we do think that these are effective, and we're hoping to run another one of these workshops in another one of our ports here in Rhode Island, in the Port of Galilee next. So this was a big group of researchers, including Rick Burrows, also in the Department of Marine Affairs, a steering committee that had folks from all across the state and federal government, and then a whole load of students. And many of the students are actually here at the workshop today because, little did you know, we are in class right now. It was a nice coincidence that this was happening at the same time as class, so the students could actually participate here. So that's what I have to say on that, and I will stop there.